Hi, Assalamualaikum. So today I'm going to explain for question 1B code. So as you can see here, before I explain a little bit about the code, I'm going to compile this first. And as you can see here, it shows 1 succeed and 0 fail. And then I just click on build lab work. Again, it shows 1 succeed and 0 fail. And before I debug this, I'm going to explain a little bit about the code. So let's start from this part about the data. So as you can see here, I initialize 4 variables, which is val1, val2, val3, and also the final val. So basically, I just initialize val1 with 10,000 H, val2 with 40,000 H, val3 with 20,000 H. So as you can see here, the words I just initialize with the word size, and H here means hexadecimal. So for final val, I initialize with question mark because that means I didn't have a value for final value because I'm going to use this final value for the calculations. Okay, moving on for the code. So as you can see here, I use move here because I want the code to move the val1 into the EAX here, and then for the second line I want to add value 2 into the EAX. I mean val1 I want to add with EAX, and then if I'm moving on to the next line, I want to subtract val3 with EAX, and then last one I want to move the EAX into the final val. So basically that's what the code is going to do. So let's start with debug this. So I just click on step over. So before that, I'm going to show you, this is the memory part, this is the watch part, this is the autos, and also this is register. So I'm going to show you the address for the final val. Oh, sorry. Final val. Alright. So here the final val. Okay. It shows here 000, which means the final val still has no value, which means 000. So let's start with this step over. So as you can see here in autos section here, it shows that EAX has no value, still has no value, but it shows val1 has 10,000. And then if I click on step over again, it shows now the EAX now having 10,000, and it shows val2 having 40,000. And then it goes saying to the next line, it shows that val3 has 20,000, but now EAX have 50,000 because the code over here, because val1 add with val2. Okay, now moving on to the next line, it shows here that EAX now having 30,000 because it's already subtract with value 3, but still the final val still has no value because we're still not moving on with the last line, which is move final val. So after I click again on step over, now it shows the final val has 30,000 value. So basically that's what the code is going to do. So yeah, so from this memory part, it shows now that the final val here, it shows 3 here because now they have 30,000 in the address. Okay, I think that's all for me. Thank you.
So in our lab 1, I will be doing the question for the part 2, question C. And the code is similar with the question B. But I will be explaining it anyway. So before I show you guys how to debug, I will be explaining the overview of the code part by part. Okay, so first, this is the comment segment. This is where we put our description about our program. Okay, and this part, this is the dot data segment where we write all of our variable and we initialize it with values. For example, this line for the variable name as value word 1, it is initialized with 1000 value of 1000 in hexadecimal with the size of one word. If you see this line, it has the question mark symbol where it means we didn't initialize it with any value. So the final value W has an unknown value. It same goes to this below code, but the difference is we use it in byte size. So this is our code segment. And after we execute this part, then we will be exiting the program. Okay. For this part,
This meeting is being
I will
recorded.
explain line by line for the code flow. Okay. For this first line, we have this move. It means like we move this value with this variable value word 1 to the AX. As we all know, value word 1 is initialized with 1000 in hexadecimal. So now AX has the value of 1000 hexadecimal. For the second line, we will be adding the value W2 to the AX. So 4000 plus 1000 will be equal to 5000. For the third line, we subtract the value W3 from AX, which is the AX is 5000 and we will be subtracting with 2000. So the variable AX will have the value of 3000 hexadecimal. And this part, it will move the AX value to the final value. So it will store the result of 3000 in the final value. And lastly, we will call dump register to display all of the register. Similar with this, but using the different variable. Okay, so moving on to the debugging process. But before, we need to compile. Okay, success. And we build the lab. Okay, success. So to display all of those windows, go to the debug and press tab over or just press the F10 in your keyboard. Okay, so this all of these windows will be displayed, or you can display it manually. You can go to the debug windows, and this is the memory, disassembly registers, watch, and autos. So the code will be executed started from here. Okay, so this is the memory window, watch window, register, autos, and disassembly. So this is the memory part, where it stores the address. So for example, I want to search for, we just enter and this symbol and put our variable name and enter. Okay, so this line is equals to this line, but in hexadecimal. Okay, same goes to the other variable address. For the watch, part, you have to add item, which is all of your variable, manually one by one to see the value that is stored in the variable. So for example, for the value word 1, we initialize it with 1000 in hexadecimal, right? So all of the value is displayed in hexadecimal. For the value byte 1, it is initialized with 10, 40, 20. And on both this final value has no value since it wasn't initialized with any value. Okay, so this is the register part where all of our address is stored, and this is auto. Auto's window will be displaying everything that we execute in real time. Okay, so this part we will press F10. When I press F10, you can see the value is changing from the value word 1, we move it to AX. Now AX is equal to 5000. When we press F10 again, you can see at the uh, yellow arrow where it is executing. And now AX is equal to 3000 since we already subtract it. And we store the AX in the final value. And then it will display all the register. Okay, now we move it to the next for the byte 1. So we start with AH. AH now has the value of 10, which is from the variable value byte 1. And then AH now equals to 50. And AH is equal to 30 after subtracting it with 20. And now the AH equals to 30 will be moved to final value by. Okay, that's all. For the last part, the disassembly part, it will show you all of this information: memory address, source code, code bytes, symbol names for the memory address, and line number corresponding to the source code. So this is the code that is displayed in byte. All of those information I stated here, you can find it in the disassembly window. That is all from me. Thank you.